All right, here we're just going to look at a couple examples of graphing rational functions, and this is just a couple extra practice type of examples. I'm going to do one of each style, meaning really referring to the horizontal versus oblique asymptotes, because that's where we really get tripped up with things. But all of these problems start off the same way. I always want to find the domain restrictions. So when I look at this first one, if I want to find the domain restrictions, I essentially just look at this thing and set the denominator equal to 0. Okay, I want to know what's going to make the denominator equal 0 because that's what x can't be. So I'm going to take that off to the side. Say, all right, the 2x squared minus x minus 3 cannot equal 0. And I just want to solve this thing for x, okay? So I'm going to build a bridge and I'm going to factor. So I build a bridge. That gives me a negative 6. The two numbers that multiply to negative 6 but add to a negative 1 are a negative 3 and a positive 2. And since I have a 2 out front, I can't just go right to my two factors. I have to split up the middle term and factor by grouping. So I'm going to do a 2x squared minus 3x plus 2x minus 3 cannot equal 0. And I'm going to solve by factoring, okay? And I'm going to factor this thing by grouping. So I group the first two together, group the second two together. Out of the first group, I can factor out an x, leaves me with a 2x minus 3. Out of the second group, you have to factor something out with factoring by grouping. So the only thing I can factor out is a 1, leaves me with a 2x minus 3. Again, the whole thing cannot equal 0 still. And now when I look at this thing, I can see my two factors. It's going to be the 2x minus 3, and it's going to be the x plus 1. Again, it can't equal 0. But now I just set each factor. I do each factor individually. So I say that the 2x minus 3 cannot equal 0. And I also do the x plus 1 cannot equal 0. All right? And I solve each of these. This first one, when I solve it, I find out that x cannot equal a positive 3/2. The second one, when I solve it, I find out that x cannot equal a negative 1. All right? Those are my domain restrictions. That's what x cannot equal. Okay? So for my domain up here, I'm just going to say, all right, x cannot equal a negative 1 or a positive 3/2. All right? And that's it. Okay? So the domain restrictions, we set the denominator equal to 0, and we solve. We find out what x can't equal. All right? From here now, I want to simplify this fraction, okay? Because the simplification tells me what's going to be a vertical asymptote or what's going to be a hole in the graph. See, these domain restrictions, each one is either a vertical asymptote or a hole in the graph, and the only way to tell which one is which is to simplify the expression, okay? So I'm going to simplify this thing. I'm going to factor it completely. So this numerator, I build a bridge, I factor. This is going to factor into an x plus 2 and an x plus 1. The denominator, I already factored once. I factored it right here. Right down here, it was a 2x minus 3 and an x plus 1. So I factored it that way, a 2x minus 3 and an x plus 1. And now I cancel out any common factors. So when I look at this thing, I've got a common factor of x plus 1, so I'm going to cancel those out. And after I cancel out those x plus 1s, I'm left with an x plus 2 over a 2x minus 3. And I should always write that down. A lot of people don't write down that simplified version. It's really important to have that because everything else I do with this function, I'm going to think about this guy. I'm going to think about y equals x plus 2 over the 2x minus 3. That's what I'm going to be using for most of the values that I find from here on out. Okay? And now from here, I'm going to erase this work that I had off to the side finding the domain restrictions. Just so this thing doesn't look so cluttered. I kept it around just to show that I already had this thing factored. But now I'm going to move on to vertical asymptotes and holes in the graph. So I look at each domain restriction. So I look at this first one. I look at the x cannot equal a negative 1. That negative 1 is either a vertical asymptote or a hole in the graph. So I look to see if that restriction got canceled out. That negative 1 came from the factor of x plus 1. And since the x plus 1 got canceled out, it means that the negative 1 also got canceled out. So since that restriction got canceled out, it means that it's a hole in the graph. Okay? So that negative 1 is a hole in the graph. To find the other half of that hole in the graph, what I'm going to do is I'm just going to plug that into my simplified version. So I'm going to plug that negative 1 in here for x into this simplified version. In the numerator, negative 1 plus 2 is a 1. In the denominator, I get a negative 5. So I get a negative 1/5 for this thing. Okay? And so I'm just finding that ordered pair, all right, by plugging in the x value. Now I look at the next domain restriction. Again, this domain restriction, the 3/2, is either a vertical asymptote or a hole in the graph. Well, that 3/2 came from the 2x minus 3. Since it did not get canceled out, it means that that 3/2 is a vertical asymptote. If it gets canceled out, it's a hole in the graph. If it doesn't, it's a vertical asymptote. So my vertical asymptote for this one is x equals the 3/2. Okay? And now when I go to horizontal or oblique, now I look at the degrees of these things. So like the degree of the numerator is 2, the degree of the denominator is also 2. When the degrees are the same, it means I'm going to have a horizontal asymptote. And when they're the same, I just divide the leading coefficient. So here I've got a 1, down here I have a 2. 1 divided by 2 is a 1/2. So it's y equals 1/2. Okay? And now from here, y-intercept and x-intercept, these are the same as they are with any function. The y-intercept is when you plug a 0 in for x. So again, I'm going to come over to my simplified version, and I'm going to plug a 0 in here for x, which is going to give me a 2 over -3, which is a -2/3. So the y-intercept, when I plug a 0 in for x, I got out a -2/3. The x-intercept is when you plug a 0 in for y. So again, I go to the simplified version, I plug a 0 in for y, and keep in mind, when I plug a 0 in here for y, if I write this above this thing, if I plug a 0 in here for y, I can either solve this by cross-multiplying, or just remember the shortcut, I can just set the numerator equal to 0. And if I just have this numerator, the x plus 2 equals 0, I just have to subtract the 2, and I find out that x equals a -2. All right? So my x-intercept is a -2, 0, and now I can move on to graphing this thing. All right? When we graph, you should always start with the asymptotes. So I'm always going to start with the asymptotes, the vertical and horizontal asymptotes. So the vertical asymptote at x equals 3/2, which is like 1.5. And again, I just do a dotted line for the asymptotes. For the horizontal asymptote, that's going to be at y equals 1/2. So I go up to 1/2 and I put a dotted line. Okay. And now from here, I just start plotting the points. The first point that I have is my hole in the graph. So right here, the hole in the graph is at -1, -1/5. So -1, -1/5 is down here somewhere, so I put an open dot. I've got a y-intercept of a -2/3, which is right around here. I've got an x-intercept of -2, which is right here. And that's enough information to graph this thing. I know that I'm going to hug this line and go through these points and hug the other line and have a nice gentle curve here. So I just do my best. I draw a curve that hugs those lines and goes through the points, and that's it. All right? That tells me what's happening in this half of the graph, but I need to know what's happening in this half of the graph. I'm either going to have a curve that's up here somewhere, or I'm going to have a curve that's down here somewhere. And the easiest way to find out where that curve is going to be is I just need to plug in some values. This is where I need to just do a little bit more work and do something like an XY chart. So if I come over here off to the side and do an XY chart, I just need values from that end. So I'm going to plug in something like I don't know, a 2 or a 3 in there. Values that are on that side of the graph. And again, when I plug them in over here into the simplified version, okay? So I'm going to plug those things in here for my x and see what I get out for y. When I plug a 2 in, that gives me a 4 in the numerator. And it gives me, let's see, a 1 in the denominator, so that's going to be a 4. When I plug something like a 3 in, it gives me a 5 in the numerator. It gives me a 3 in the denominator, so it gives me like a 5/3. And so if I plot these, let's see, 2, 4 is right here. 3, 5/3, that's like 1 2/3. So 3, 1 2/3 is right about there. So that gives me plenty of information to graph this thing. I know I'm going to hug the line, go through these points, and hug the other line. And it's going to be a nice, gentle curve, so it kind of shows me where this thing is going to be. Okay. So again, we use the values we have, we plot those, see what it gives us, and then from there, we just plug in more points to see what the rest of this thing is going to look like. Okay. We know it's rational, so we know it's going to be these kind of dueling curves. We just got to figure out where they are. Okay. If I look at this one again, I start off the same way. I'm going to set the denominator equal to 0. Actually, I can bring that up here a little bit. So x squared minus 2x minus 8 cannot equal 0. And I'm going to solve this thing by factoring, so I'm going to build a bridge. So I build a bridge that gives me a -8. The two numbers are going to be a -4 and a +2. Since there's a 1 out front, I can go right to my two factors on this one. So it's x minus 4 times an x plus 2 cannot equal 0. And now I set each factor equal to 0 or not equal to. So I find out that from this first one, when I solve, I add that 4 to each side. I find out that x cannot equal a +4. And from the second one, I find out that x cannot equal a -2. All right, so those are my domain restrictions. X cannot equal -2 or +4. From here, I just have to simplify this thing completely. So I'm going to simplify it as far as I can. I'm going to factor everything completely. That numerator I can factor out a 2, which leaves me with an x plus 2. The denominator I already factored once. It factors into an x minus 4 and an x plus 2. And now I cancel out any common factors. The x plus 2's cancel out. And so what that leaves me with, it leaves me with a 2 over x minus 4. Again, I should write down this simplified version. See, now I know I'm dealing with something like y equals 2 over x minus 4. All right? So now I look at each domain restriction. It's either a vertical asymptote or a hole in the graph. The negative 2, this first domain restriction, came from the x plus 2, which got canceled out, which means that is my hole in the graph because it got canceled. To find the other half of the hole in the graph, I have to plug it into this simplified version. When I plug a 2 in there, I get 2 over 2 minus 4, which is a negative 2, and 2 divided by negative 2 is a negative 1. The vertical asymptote is going to be this guy. Notice right here, the 4 came from this factor, which did not get canceled out. Therefore, that is a vertical asymptote, so it's x equals 4. Horizontal versus oblique, I look at the degrees again. This is like an x to the first. So when I look at these degrees, here I have a 1, here I have a 2. When the denominator is bigger like that, it's automatically going to be horizontal, and it's automatically going to be y equals 0. Okay? And now from here, x and y-intercept, same thing. The y-intercept is when I plug a 0 in for x. And again, I'm going to go to my simplified version. There's no reason to plug it into the original. I'm going to go to the simplified version. And if I plug a 0 in for x right here, I get 2 over negative 4, which is a negative 1/2. So it's 0, negative 1/2. The x-intercept, I plug a 0 in for y. Again, I'm going to do it into the simplified version. Let me do it right above this thing. If I plug a 0 in here for y, again, I could solve this by cross-multiplying, or you can just set the numerator equal to 0. So if I do 2 equals 0, that's ridiculous. That doesn't make any sense at all. It doesn't work, so I don't have any x-intercepts. Essentially, when I try to solve, I get no solution, so that's none for the x-intercepts. All right? Which makes sense because I have my horizontal asymptote there, and a lot of times we'll hug that line without touching it. Okay? So now again, when I graph, I start with the asymptotes. So x equals 4. I graph as a dotted line. Y equals 0, I graph as a dotted line. I start plotting these points. The hole in the graph is at negative 2, negative 1. So negative 2, negative 1 is down here. I do an open dot. From here, I have to plug in the y-intercept. The y-intercept is at a negative 1/2. Something has gone wrong here. Oh, my hole in the graph is a little bit off. And right away, let me just show this. As I went to plot this thing, obviously I plugged something in wrong. If I've got a y-intercept here at negative 1/2, that's an issue because there's no way I can hug these lines and go through both points. What happened was when I plugged my y-intercept, or my hole in the graph in, I made a mistake. So here, when I do the negative 2 in there, I get negative 2 minus 4, which is a negative 6. So I have 2 over negative 6, which is a negative 1/3. And so if my hole in the graph is actually at a negative 1/3, now this makes a little bit more sense because it gets closer and closer to that line. Sorry, it's at negative 2, negative 1/3. So it's right here. So now I know that this thing hugs this line, it goes through these points, and it hugs this other line. Okay? And if I want that to be more accurate, I can plug more points in. But again, I need to know what's going on over here, so I have to do an XY chart. Okay? And I just need to choose values over there on that side of the graph, so I'm going to choose something like a 5. I'm going to plug a 5 in. Again, plug it into the simplified version. You get 2 over 1, which is a 2. So I get the ordered pair 5, 2, which is right here. And now that's enough information to graph. I go through the point and hug the lines. And that's it. I'm just drawing a quick sketch of this thing. Okay?